In this video, I'm going to present elements of the Mathematica user interface. For the most part, Mathematica documents called notebooks are transparent and self-evident in the sense that they all of the inputs are typed and you can see everything that went into producing the outputs that the notebook contains. Manipulating the notebook itself is another story because it involves the cursor and the mouse and clicking on things and that sort of action, so that you cannot tell how certain things were done by looking at the finished product. So I'm going to begin by just typing in a little piece of input to make a plot, and I won't describe in detail the functions that I'm using because my focus here is more on how you interact with the notebook itself. So here I've typed a piece of input that's going to make a plot of the function sine of x. It's pretty self-evident what I'm doing here. And I've typed it in, but I haven't yet executed it. And to actually make Mathematica do this, while I'm in this line, I type shift return or shift enter. And then I get this plot. You'll notice that when I do, I get input and output numbers next to the input and the output that Mathematica produced. If I want to make a change in this line, I can just go in, click back in, and type and change, for example, the range of the plot here, and execute it again with shift enter. So it's the essence of Mathematica that if you don't quite like what you got, you can change it and do it again. Over here on the right, you'll notice these narrow little gray lines that bracket or group here the input, here the output, and here the input and output together. These brackets and their contents are called cells. And so this is an input cell, that's an output cell, and this is a grouping. And the grouping has a number of properties, one of which is if I double click on it, it folds up. And the little arrow underneath indicates that there's something inside here which I can reveal by double clicking again to unfold it. This is useful in the case of input and output cells to hide lengthy output. Cells can also be copied and pasted by highlighting and then using the usual control, or on a Mac, command copy and command V for paste. So if I want to copy this input cell, I can do that, and then I can go down here and click in at a different spot and then command V to paste it in. And I might do that, for example, if I wanted to change slightly the result without destroying the old one. So I'll plot here sine and cosine together and shift enter to execute that. And then I can have the plot of the two functions on the same graph. Another way of getting the previous input as a line of new input is by using command L for last input. And I want to also point out that to make a new cell somewhere, if I move the cursor around, you'll see that it changes shape. It's vertical when it's ready to be clicked into a line of existing input, and it's horizontal when it's between cells. And if I click there, then this horizontal line appears, and I know that I'm ready to make a new cell there. And one of the ways is just by typing a line of input, and it will start making an input cell. And another, as I mentioned, is by command L, which copies the previous input line. And then I can modify it and execute it. Here I don't want this, and so I'm just going to get rid of it by clicking on the cell and pressing delete. So cells can be deleted. In fact, entire groups can be deleted in this way, as well as copied and pasted, as I showed before. And if I do that, there is a limited amount of undo with the usual command Z to undo it. But here I really do want this gone, so I'm going to take it away. Now I want to look a little bit more closely at this point on some of the prompts that Mathematica gives as you're typing input. So as I start typing a line like plot, you can see that it make suggestions as to functions I might have in mind. And if I want one of those, I can go down here and click on it, or if I just simply want to auto-complete as it's suggesting, I can hit Tab and it will give me the whole function. And then when I type a left bracket to start putting the arguments of plot, you see it automatically makes a right bracket to match, so I don't forget it. And as I type sign, again it prompts me for an autocomplete. And if I type the brackets where the argument's going to go, and I put an X, now I see a little red caret. And the little red caret is telling me I'm not done with the inputs to plot, which if I hover over the caret, it actually reminds me what I need, which is a comma, and then the range of the plot, like so. If I were typing along and modified this line and I was missing a bracket, then you'll see that the unmatched bracket shows up as a sort of purple color. And when that bracket matches, it briefly flashes to show that the mating bracket has been entered. If I put an extra bracket, you'll see it's this purple color again, and again unmatched. And so Mathematica prompts you to match the brackets properly. One of the really useful things about a Mathematica notebook is that it's easy to put comments and headers into the notebook so that it is a self-documented notebook. So for instance, I can click in here, and if I want to make a text cell, then from this menu here I can choose text, and instead of typing an input that Mathematica will interpret as something to execute, I can say comment about the line below. Like so. And if I want to put a comment about this line above, then I can go up here, wait for the horizontal cursor, click in, and likewise insert a text cell. Another way to get a text cell is under Format Style Input. Instead, that's the default for input to Mathematica, then text, and then I get a text cell. Not only can you put in text lines, but you can put in sectioning and header lines. So for instance here, I can insert a section head, and you'll notice that underneath that, the bracket for this groups the entire contents below. In fact, that grouping would continue all the way to the next sectioning command. So if I had an additional plot function, that would be grouped under here and so on. And then if I fold this up, it all disappears and can be unfolded again. And so the sectioning commands allow you to group the document in a way that you don't have to look at everything at once. If I put a sectioning command above here, it will group everything down to the next matching sectioning command. In other words, sectioning command of the same hierarchy. There are sections and subsections and sub-subsections. So for example, a sub-subsection command looks like a subsection command looks like this. And so it groups only what is underneath it to the next matching level. And so section and subsection cells group everything below them up to the next section or subsection of the same or higher hierarchy. As another simple example to work with, here I'm going to make a table of data and then plot it. First I'll put in a sectioning head, and then I'll make a table using a very general and useful function called table. This will make a list of pairs x and the corresponding value of sine x, and x will run from 0 to 8 pi in steps of pi over 8, let's say. If I do that, I get a big long list of pairs, which maybe I don't want to look at, so I can either fold them up as I showed before, or I can put a semicolon after this and execute it again, and this suppresses the output. I can take this data set and plot it, not with plot, which is for plotting functions, but with list plot. If I want these points to be joined, I can add the options join goes to true and mesh goes to all, which will show the lines connecting the points as well as the points themselves. Sometimes it's useful to use the semicolon not just to suppress output, but to stitch several lines together in such a way that only the final line appears, in such a way that the output from the final line is the only thing that appears. So here I will make 2 tables, one of sine, one of cosine, and then I will list plot them together. And here I'm just using cut and paste to grab the text from the previous cells to modify. And one can list plot the 2 of them together. And the semicolons have suppressed the long output of each of the tables. Sometimes you want to clear values from a symbol because you want to use it again for some other purpose, or because there's some inadvertent conflict between your earlier use of it and some later use. To find out the definition of a variable, you can just type it and then Shift Enter to see, and you can find out its current value. And if you want to clear its value, then you use the function clear. And when you do that, you'll notice that all occurrences of tab 1 in the notebook have turned blue instead of black. And blue is Mathematica's way of telling you that it does not have a definition for this symbol. When I re-execute this group of lines, then tab 1 turns black because now it has a definition. If you are frustrated with your definitions and you want to clear absolutely everything, which is a rather drastic step, then you can type clear all and then the following global back single quote star. That clears everything in what's called the global context, which is what you're working in when you're working in the notebook. I'm not going to execute this, but that is the line that would clear absolutely every definition that I've made. Sometimes you want to stop execution on something that's taking a long time, typically some mistake that you've made, and Mathematica is running and trying to do what you asked. As an example of that, I will ask it to find the intersection between the lines 4 minus x and e to the x, but not just one time. I'll ask it to find it 100,000 times, and this will take about 15 seconds. And if I get bored waiting, then I can go up to the top menu and tell it to stop the evaluation with evaluation abort, and then it will quit. Every so often, Mathematica stops listening and abort evaluation doesn't work, and then you can stop things absolutely drastically by quitting the kernel. That will leave you in the state that you were in when the notebook first opened. That is, no definitions will have been made, all of the input and output lines will be present, but you'll be looking at a fresh notebook the way it would look if you opened it after having saved it. Mathematica, being a commercial program, has extensive inbuilt help, and there are several ways of accessing it. If you know the name of a command and you just want a brief reminder about how to use it, you type question mark and then the command name and then Shift Enter, and you get a little prompt about essentially the format of its arguments and briefly what it does. If you want more information, then if you click on this little I here, it opens the Documentation Center with the article on that function, which has extensive examples, all the different options, and what you'll discover is that functions that you know actually have many more options than you were aware of, which is a nice feature of the language. You can do a lot without knowing all the details. You can access the Help Center here, and you can ask it questions. And it is aware enough to give you reasonable responses. Here's the plot article we were looking at. There are also more general articles. For example, this one here tells about plotting in more generality, different kinds of plots, how to combine them, how to plot data, and so forth. And it's a tutorial article which has many examples and is reasonably extensive.